So it's just me. So don't have to worry about the privacy stuff here because no one's going to see you. They're only going to see PowerPoint. Okay, so without further ado, dimensional analysis. Dimension is a scientific word for unit. So dimensional analysis is using the units to solve the problems. So if you get the units right, you probably set the problem up right. If you get the units wrong, you definitely set up the problem wrong. So remember,
Are you sharing your screen?
I thought I'd share the screen. It didn't share? Okay, let me. Huh. All right, let's try again. There's that better? Hey, give me a second. 3, 2, 1. Yep, that looks like that's the right. There we go. Oh, nope, you're seeing my side, so I got the wrong one here someplace. Too many windows. There we go, that looks better. Okay, so old friends, conversion factors are 1. Okay? So conversion factors equal 1, so I have to have two things that are equal. 1 foot is 12 inches. That's called an equivalent statement. And so that I can write 12 inches over 1 foot is going to be 1 because the thing on the top and the bottom are the same. Or 1 foot equals 12 inches, the top and the bottom are the same. All of those are equal to 1. So every equivalent statement gets you two conversion factors. You just have to decide which one to use, and you use the one that gets rid of the units you don't want. So you want to multiply one that gets you the right units as your answer, but your focus should be getting rid of the units you have because they're the wrong ones. Okay? And think of a plan that you can get rid of the ones you have and turn them into the ones you want. So what could you use dimensional analysis for? Okay, because you never learned dimensional analysis, you've been working at a fast food restaurant for the past 35 years wrapping hamburgers. Each hour you wrap 184 hamburgers. That's over 3 a minute. You work 8 hours a day. You work 5 days a week, get paid every 2 weeks with a salary of $80.40. How many hamburgers would you have to wrap to make your first $1 million? So, how are we going to do that? Okay. Well, what I see is what I see is a bunch of equivalence factors. I see that each hour is 184 hamburgers. So 1 hour equals 184 hamburgers. 8 hours each day. 8 hours equals 1 day. 5 days equals 1 week. Paid every 2 weeks with $840.30. So 2 weeks equals $840.34. And now the question, how many hamburgers would you have to make your first $1 million? That's the question. So part of it is going through and seeing what the relationships are, and the other part is figuring out what the question is. And notice I have my question in terms of units. I got dollars and I got hours. So I want to start with the $1 million and end up with the number of hours. So I take my pen decided not to work. Okay, do I have another one here? Yep. So I take my $1 million and I want a conversion factor that gets rid of the unit here, and the unit here is dollars. So I have to pick a conversion factor that has dollars in it. Okay, what I know about dollars is that $840.34 is 2 weeks. And my dollars have canceled out. Now I want to get rid of weeks. So weeks has to go on the bottom. What can I turn weeks into? Weeks I can turn into days. 5 days, 1 week. And my weeks are gone. Now I'll be able to get rid of days and turn them into hours. 8 hours in 1 day. That gets rid of days. Now I want to get rid of hours and turn that into hamburgers. And 1 hour is 184 hamburgers. So now all I have to do is, because I got the right unit, I just have to push those buttons on my calculator. So I push the buttons on my calculator. 1 EE6, because I'm too lazy to write a million, times 2, because it's on the top, divided by 840.34, times 5, times 8, times 184, so my calculator gave me this number. 175, 167.19. 0.42. Hamburgers. That's a lot of hamburgers. But is it the right number of sig figs? Oh. Sorry, I got to come back to this in a second. It just messed up on me. Sorry about that. It messed up. So I got to get back to it. Okay, there we go. Sorry, we're back. Okay, so I've got a lot of hamburgers got to make, but how many of them do I actually get to write down? So I got to figure out the number of sig figs in each of these conversion factors. Okay. $1 million. How many sig figs in $1 million? Well, the question was, how many hamburgers until you make $1 million? So that $1 million is a definition. So it is unlimited. I work exactly 2 weeks to make $840.34. Well, it's a salary, so it doesn't change. So the 840 is unlimited, and the 2 weeks is the definition, so that's unlimited. 5 days in 1 week. Why 5 days in 1 week? Because that's the definition of a work week. It's a definition. Unlimited. 8 hours in 1 day. Why 8 hours in 1 day? Because that's the definition of a work day. So that's unlimited. 184 hamburgers in 1 hour. How do you figure out you make 184 hamburgers in 1 hour? Well, you make a bunch of hamburgers and divide it by how long it took to make those hamburgers. And every hour, you're probably not going to make exactly 184. Okay? That's probably like the average number of hamburgers you make, because you can't make exactly the same number of hamburgers every hour. So that's a measurement, and since that's a measurement, it has 3 sig figs. Because I make about 184 hamburgers an hour. So my smallest number is 3 sig figs. So if I want to make $1 million, 1, 2, 3, 175, 0, 0, 0, 0, 0. To make $1 million, I have got to wrap 17,500,000 hamburgers. And that's not a career anybody wants. Okay? So you can take really, really long and complicated questions and break them up into individual pieces, and you don't have to think about whether to multiply or divide. Let the units tell you how to do the problem. Okay? One of the problems we run into doing this is, what do you do with cubes? Because a meter cubed, how many meters cubed is 1,500 centimeters cubed? We're talking about a cube where every side's a meter, which would mean every side was 100 centimeters. So while one meter equals 100 centimeter, one meter cubed has to equal that's length times width times height, has got to equal length times width times height, that 100 centimeters cubed. But the cube has to go outside. Okay. So there it is graphically why we do it this way. Here's what it looks like with just the math. If I had 1,500 centimeters, I could use a conversion factor to get rid of centimeters. Get rid of centimeters here, but it wouldn't get rid of centimeters. It would turn that into centimeters squared. I got rid of one of the centimeters, I need to get rid of another. So I do another 100 centimeters, 1 meter over 100 centimeters. That cancels out centimeters here, and now I'm just down to centimeters to the first. So I have to do it one more time. 100 centimeters. That crosses out centimeters, and it gets rid of it completely now. And now I have meters, meters, and meters on the top, so that's going to be meters cubed. Okay. So I can take 1,500 divided by 100, divided by 100, divided by 100. This is a measurement. These are all definitions, so they're unlimited sig figs. So that would be 1,500 divided by 100 divided by 100, which is 1.5 times 10 to the minus third meters cubed. Because if you take 1,500 divided by 100, divided by 100, divided by 100, it gets you 1.5 times 10 to the minus third. Okay. Now, we're too lazy to write all those 1 meter over 100 centimeters. So instead, we write the 1 meter over 100 centimeters and we cube the whole conversion factor. That means we cube the meters, which is what we want. We cube the 1, which has no effect. We cube the 100, which is going to be a big number, and we cube the centimeters so it cancels out. Now the challenge is, how do we get that into our calculator? Because The idea is not hard, but you got to make sure you do it in the right order in your calculator. So let's see if I can make this thing work. Where's my mouse? There it is. It should be over here. So, $1,500 divided by 100 x to the y cube. And you see up here in my thing it says 100 divided 1,500 divided by 100 cubed, and it gets me 0.0015, which is 1.5 times 10 to the minus third. So I had to cube the 100. Okay. So rather than writing it 3 times, write it once and put the cube on the outside. Okay. So let's try a couple others. Okay. So I've had 15 centimeters squared. Goes how many meters squared? I want to get rid of centimeters, so it's got to go on the bottom. I can turn centimeters into meters because I know the metric system. 1 meter is 100 centimeters. But I need to get rid of centimeters squared, so I put the squared outside.
Wait, Mr. Green, isn't it 15 meters squared?
Oh, you know what? I got it backwards. I copied badly. So that's something I can't fix. So now I got it upside down. Thank you. Okay, so 15 meters squared. Now I want meters on the bottom, and I want centimeters. There we go. So it's the same numbers upside down. 1 meter is 100 centimeters. I want to get rid of meters squared, so I square everything. So when I push that into my calculator, come on, mouse. I get 15 times 100 squared equals 150,000. Okay? So it doesn't matter whether it's squared or cubed. Okay? What if they both have prefixes? Well, we don't do anything that different. I write my 36 centimeters because I copied it right this time. I want to get rid of centimeters. I can't go from centimeters to millimeters. I'm not going to try to remember all those relationships. But I go from centimeters to meters. 1 meter is 100 centimeters. But it wasn't centimeters, it was centimeters cubed. So I have to cube everything on the outside. That gets rid of centimeters cubed and leaves me with meters cubed. Now I want to get rid of meters, and I can change that into millimeters. 1 meter is 1,000 millimeters. But I don't want to get rid of meters, I want to get rid of meters cubed, so I have to cube this second conversion factor too. So, there I go. 36 divided by 100 cubed times 1,000 cubed is 36,000. Okay? And the units are millimeters cubed. Okay. So this is how we can deal with volume. Volume is cubed. But volume also comes in things that aren't cubed. So what do we do when we have a little bit of both? Okay, a gallon is 4 quarts. A liter, I should say and a liter. A liter is 1.057 quarts. how many cubic meters is 26.3 gallons? How the cubic meters? How the heck am I supposed to get cubic meters? Well, cubic meters is a volume. Okay? But I don't have anything cubed here. I got gallons. How am I going to get from gallons, things measured in a measuring cup, to cubic meters, things measured with a ruler? And that relies on those facts we learned at the end of the period on Tuesday. Because the fact I need, anytime I've got volume that I measure with a measuring cup and volume I measure in cubic, I'm going to need one of these facts. Either 1 liter is 1,000 centimeters cubed, or 1 milliliter is a centimeter cubed. I need one of those two facts. So those facts pop up every time you want to go between things with cubes and things without cubes. So in order to do that, I'm going to have to get to liters. Liters I'll be able to turn into centimeters cubed, and centimeters cubed I can turn into cubic meters. So I have a plan. So the thing he asked me is how many cubic meters is 26.3 gallons, so I write down the 26.3 gallons. For some reason, it won't take my decimal point. I don't know why. Yeah. Okay, 26.3 gallons. First conversion factor, I want to get rid of gallons. So gallons has to go on the bottom. What can I turn gallons into? Well, gallons I can turn into quarts. Okay, oops, I did it in my head. Quarts. They're called, 1 gallon is 4 quarts because it's called a quart because it's a quarter of a gallon. Now my gallons are gone, so I can get rid of quarts. What can I turn quarts into? Quarts I can turn into liters. Because 1 liter is 1.057 quarts. Got rid of quarts. Now I need to get rid of liters. And I got to liters so I could get to centimeters cubed. Because 1 liter is 1,000 cubic centimeters. So now I want to get rid of centimeters cubed. But centimeters I can turn into meters. 1 meter is 100 centimeters. Now this time, the cube goes on the outside. Up here it went on the inside because 1 liter is 1,000 cubic centimeters. Here I'm going from centimeters to meters, and I have to cube that change. So this cubed gets typed in your calculator, that one doesn't. So I've got the right units, so that means I probably set it up right. So now all I have to do is push some buttons. So, where to begin? Well, 26.3 gallons times 4 quarts for a gallon divided by 1.057 quarts times 1,000. And because the cube is on the inside, I don't push it. Divided by 100, and now the cube is on the outside. And the calculator gives you 0.099, 99269. That's more than I need. Okay, so then I have to think about sig figs. There's 26.3 gallons. 3 sig figs. 1 gallon, 4 quarts. Same system. They have unlimited sig figs. Why is 1 gallon, 4 quarts? Because that's the definition of a quart. 1 liter, 1.057 quarts. One of these came from the metric system, the liter. The other one came from the English system, the quart. If you have one from each system, your conversion factor has as many sig figs as the most in the conversion factor. I can't know this to 4 sig figs unless I measured my 1 liter that carefully too. So I have to have measured the two pieces to the same degree. So this has 4 sig figs. 1 liter is 100 centimeters cubed. That's a definition, unlimited. 1 meter is 100 centimeters. That's a definition, unlimited. So my smallest number of sig figs is 3. So that is 0.0993 meters cubed. So hopefully you see the difference about why I put the cubed inside here versus outside there. Now, every one we've done so far has only had 1 unit. What if it has multiple units? What do? Well, you'll follow the same rules. Okay. Uh, 65 miles per hour. Notice how I took this slanted one and changed it to a vertical fraction. That's so I can see a clear top and bottom. Okay, so my first conversion factor has got to get rid of something. It can either get rid of miles or it can get rid of hours. You can't change both at the same time. So it doesn't matter which one you pick. The answer will be the same either way. I tend to pick the top to start with. So I put miles on the bottom, and what do I know about miles? I know a mile is 1,760 yards. Now I want to get rid of yards, and yards I can turn into meters. So if you look at the units, I turn miles into yards, yards into meters, and now I've got the top half fixed. Everything's the same so far. Here comes the tricky part. And it's not that tricky, but it catches you because you're so used to putting it on the bottom. What unit I want to get rid of is hours. So in order for hours to cancel up, it's got to be on top. The hours has to be on top or it won't cancel. So when I make my conversion factor, I can go from hours on top to minutes on the bottom. And some of you are going to say, oh, I'm going to jump from hours to seconds. About a third of the time people do that, they put 1 hour 60 seconds. So don't try to do it all at once, or make sure you're careful about which one you use. Now I get rid of minutes because it's on the top. Or it's on the bottom, I put it up top so I get rid of it, and then I can turn it into seconds. So the only units I have left are meters on the top and seconds on the bottom. I push those buttons in my calculator. 65 times 1,760 divided by 1.094 divided by 60 divided by 60 equals 2.68129. Yeah, I can keep going, but that's more than I need. I just have to think about where to round it off. Starting at this side, 1 minute is 60 seconds, that's a definition, unlimited. 1 hour is 60 minutes, that's a definition, unlimited. 1 meter is 1.094 yards. One's metric, one's English. I take the most out of the conversion factor, so that has 4, so 4 sig figs. the 1,760 yards in 1 mile. Why is 1,760 yards 1 mile? Because that's a definition. 65 miles an hour. How many sig figs there? Well, this is actually a little bit of a trick question. Because where did they get the 65 miles an hour? They got it because they said the speed limit is. How do you get a speed limit? Somebody decides it. Well, since somebody is deciding it, that means it's a definition. So in this case, 65 miles an hour has unlimited sig figs. Now, if they said a car is traveling 65 miles an hour, that would be a measurement, and it would only have 2 sig figs. So how many sig figs it has depends on where you got the numbers from. So since I got that from a definition, the smallest number of sig figs I have is 4. So I have to keep 4. 2.681. And the units are meters over seconds. So if it's on the bottom, you got to put it up top to cancel it out. And how could we put all of that together? Well, it'd be one place where all of that comes together is when you have density. Remember, density is mass over volume, so you're going to have 2 units. Okay, so lead has a density of 11.4 grams per centimeter cubed. What is this in pounds per quart? Okay, so that means grams per centimeters cubed. I want to turn into pounds per quart. First thing you should do is notice that the numbers on the top are the same kind of things. These are both masses, so I should be able to turn grams into pounds. Centimeters cubed is a volume, quarts a volume. I should be able to turn a volume into a volume. So in order to do this, all I have to do is fix the units. So I'm going to start off with my 11.4 grams per centimeter cubed. I usually fix the top one first just because that's where I'm used to starting. So my top one has grams. I'm going to put grams on the bottom. What can I turn grams into? Well, if they want me to turn grams into pounds, and they gave me that, so I can say that 1 pound is 454 grams. And the grams cancel out. So I fixed the top. Now all I have to do is fix the bottom. Well, what I want to get rid of is centimeters. Actually, I want to get rid of centimeters cubed. And I need to get to quarts. Well, quarts I'm going to get from liters. And liters I can get from centimeters cubed because I've remembered that silly fact about liters and centimeters cubed, that 1 liter is 1,000 centimeters cubed. Then my centimeters cubed cancel out, and I can turn liters from the bottom, put up top, into quarts, because 1 liter is 1.094 quarts. So with that, I have the right unit. Pounds on top, quarts on the bottom. I've got the units I want, so it's button pushing time. 11.4 divided by 454 times 1,000 divided by 1.094. That is 22.95258881. Oof. Way too many way too many digits on my calculator. How many should I have? Well, density is mass over volume, so in order to find lead's density, they had to measure it. So this has 3 sig figs. Pounds and grams, different systems. So I take the biggest number in here, 3 sig figs. 1,000 centimeters cubed is 1 liter. That's a definition. It has unlimited sig figs. And 1 liter is 1.094 quarts, metric and English. So I take the biggest number, that's 4. And looking at my sig figs, there's 3, 3, unlimited, and 4. So the smallest number is 3, so I have to round that to 3 sig figs. 22, the third one's a 9. Behind the 9 there's a 5, so I round that up to 23.0. And that is pounds over quarts. And all dimensional analysis problems are just variations on this. And me talking about it shows you the basics, but the only way to get good at doing these problems is doing these problems. Right? That's the only way to get good at it, is to do them. So if you go to, I'm going to put you all into small breakout rooms so you can work together to start off, and pull you back in at the end of the period and check in along the way. All right, and what I'm going to put up is it says dimensional analysis practice number 1. You can go ahead and do that. Now, I've started grading papers that people submit. Okay, and here's what I have found. Okay, I have found that if you type into Canvas, I can see that, and I'll be able to make comments about what you got right or what you got wrong. If you do it on a piece of paper and send a picture, I'm actually able to mark it up just like I would a piece of paper. Circle what I saw, what I didn't see. But if you're going to use Canvas, Canvas has some nice formatting tools. Okay? So, zoom in. Okay. So here I am in Canvas.